Did you know that more than 90% of the universe is made of material we cannot see, touch, or accurately describe? So here's the unsettling part. If we can receive crystal clear photographs from Mars in minutes, how is it that critical images of an interstellar object have been missing for 45 straight days? On November 13th, while the world celebrated a fresh batch of breathtaking Mars photos released by NASA, a much darker question quietly surfaced beneath the excitement. If transmissions from the red planet can be delivered almost instantly, then what happened to the 3I Atlas images captured on October 2nd? Those files are still nowhere to be seen. It has now been 45 days. These unreleased photos weren't taken by some old, outdated instrument. They came from HiRISE, the sharpest, most powerful camera ever placed in Martian orbit, operated by researchers at the University of Arizona. With the computing power available today, that data should have been processed, reviewed, and published long ago. This delay isn't just unusual, it has ignited widespread curiosity and raised uncomfortable questions. Is something being slowed down intentionally, or is there information concealed behind official explanations? When I was directly asked whether I trusted the NASA administrator's reason for the holdup, I simply smiled. I said I had no issue with his statement because he was only repeating what he had been told, and frankly, so was I. But what I seek is the truth. I hope that in the coming days something finally surfaces. I'm not accusing NASA of an intentional cover-up, but the slow, tangled bureaucratic machinery behind these decisions often looks like a cover-up to the public. There are layers of information folded behind curtains that rarely open. The host nodded, repeating the one detail that made people's skin crawl. The photo was taken October 2nd, it was not released until November 13th. We ended our conversation with a promise to speak again, standing at the crossroads where mainstream science meets the vast region of unanswered mysteries. But now we need to turn to the science because something sudden and almost impossible has just occurred. A dramatic shift in the behavior of the interstellar object 3I Atlas has pushed astronomers into a state of high alert. The latest wave of observations shows that the object has begun forming a dust tail at an astonishing rate, its structure changing far more aggressively in just a few weeks than any prediction model suggested. What began as a blurred, uneven streak has rapidly sharpened into a distinct, concentrated dust tail observed in newly processed high-resolution images. This development is forcing research teams worldwide to completely rethink what they thought they understood about interstellar bodies. Then, almost on cue, an entirely separate report emerged across radio astronomy channels. A brief, unverified pulse was detected near 1020 MHz, the famous hydrogen line, one of the primary frequencies monitored in deep space SETI surveys. The signal hasn't yet been confirmed by multiple observatories, but it appeared at the exact moment 3I Atlas began its structural shift. Because of the timing, scientists are now scrutinizing every scrap of data they can gather, and predictably, the discovery has already intensified speculation and conspiracy theories surrounding one of the strangest objects ever to enter our solar system. This situation is evolving by the hour. Every new update is being tracked by observatories across the planet. 3I Atlas, the third interstellar object ever confirmed, has been under continuous surveillance since its discovery months ago. In the beginning, everything was normal. It was faint, drifting slowly, and showed almost no distinctive features, exactly what one would expect from a frozen remnant wandering in from a distant star system. But over the last few weeks, its behavior has abandoned all expectations. Its activity curve now defies nearly every assumption about how interstellar ice reacts to sunlight. The first anomaly appeared as a narrow column of material emerging directly toward the sun. This is almost unheard of. Typical comets blast material away from the sun because radiation pressure forces dust outward. But 3I Atlas was pushing material toward the light source. Instead of forming a clean, sun-opposing tail, it produced an asymmetrical, distorted, truncated jet that left scientists staring at the data in disbelief. This peculiar reversed flow behavior suggests that the material may be erupting from a localized vent or a deep fissure within the object. But even then, the direction makes little sense. Why would it be releasing gas and dust toward the radiation pressure zone? Even more baffling, this jet remains stable over numerous observation cycles. It didn't expand, twist, or evolve the way natural cometary jets do. It held its shape like something fixed, disciplined, or controlled. This stability only deepened the mystery surrounding 3I Atlas. Is it just an exotic, oddly shaped fragment from another star system? Or is there a mechanism at work that we have never seen before? As analysts combed through the data, bold theories began circulating in the astronomical community. Then, without warning, the entire structure of 3I Atlas transformed. New readings from major southern hemisphere observatories, especially from Chile and South Africa, revealed that the once sun-facing jet had reorganized into a more traditional comet-like tail, a long, sharply defined streak now stretched away from the sun, fully consistent with standard comet dynamics. What left scientists stunned wasn't just the unexpected transformation, it was the speed of the transformation. In a shockingly short span of time, the object reshaped itself so drastically that many researchers literally sat upright when the data came in. It looked as if some immense force had torn material from the core almost instantly. Now let's go deeper into the physics, because here the mystery only deepens. Initial photometric and spectroscopic analyses made the situation far stranger. Instead of the tiny light micron-sized particles that dominate typical comet dust, the tail of 3I Atlas contains surprisingly large grains, as big as 1/10 of a millimeter. In the world of interstellar dust, that is enormous. These grains are heavy, sluggish to accelerate, and extremely rare in such large quantities, yet 3I Atlas is releasing these heavy particles in a smooth continuous flow drifting outward at just a few meters per second. There are no signs of explosive jets, fractures, or violent outbursts, no pressure spikes from sublimating ice. It is a slow, ordered, almost intentional release. This suggests that the interior of 3I Atlas is not a loose bundle of primordial ice. It may be denser, more structurally cohesive, or even layered, with each layer responding differently as sunlight penetrates deeper. The more astronomers studied this strange wanderer, the more the puzzle deepened. What they first assumed was just another frozen traveler from a distant star began revealing behaviors that didn't line up with anything comfortably familiar, and that forced an uncomfortable question into the conversation. Was this merely an icy relic drifting through interstellar darkness, or were we witnessing a physical process that has never once appeared inside our solar system? Even the most grounded researchers felt the ground shift beneath their assumptions when the spectroscopic data came in. Somehow gases from 3I Atlas began streaming off its surface when it was still nearly 3.5 astronomical units from the sun. That kind of distance is brutally cold, far too cold for ordinary water ice to escape into space. At that range, only the most volatile molecules in the universe, like carbon monoxide or carbon dioxide, could sublimate. And yet the signatures appeared not only early, but violently strong. The implication was unavoidable. 3I Atlas carried a reservoir of hypervolatile materials, the kind that form at the frozen outer rim of a young star system, a region so cold it hovers just above absolute zero for billions of years. Our own solar system has such places, the Oort cloud and the Kuiper belt, but the numbers didn't fit. The trajectory didn't match anything that originated here. Its motion whispered a different story. 3I Atlas didn't come from our sun, it came from somewhere far beyond. And then came the detail that turned scientific curiosity into uneasy fascination. Because the weird gas activity was strange enough, but it was nothing compared to the rumor that spread through the radio astronomy community like a quiet wildfire. Networks observing hydrogen-line frequencies suddenly reported a pulsing fluctuation near 1,220 MHz, a frequency so iconic that SETI researchers practically treat it as sacred ground. It is one of the quietest natural regions in the electromagnetic spectrum, a cosmic whisper zone where interference is minimal and delicate signals stand out sharply. More importantly, it's the very frequency SETI designated decades ago as the universal hailing channel for any civilization that wants to be noticed. In the world of cosmic communication, 1420 MHz is the cosmic North Star, the place you'd broadcast if you wanted your message to be unmistakably intelligent. That coincidence, the strange behavior of 3I Atlas, and the brief pulse heard exactly at the hydrogen line forced even the most skeptical scientists to pay attention. They weren't jumping to conclusions, they weren't declaring contact. But they also knew that in science, anomalies are not mistakes. Anomalies are invitations, and this one felt like a door someone had cracked open. The pulse was fleeting, lasting only seconds, captured by just a handful of independent receivers scattered across different continents. Not one of those readings has been fully authenticated. It could be a terrestrial glitch, atmospheric scattering, or something completely unrelated. But the timing, the way the pulse aligned with a sudden surge of activity in 3I Atlas, pushed several observatories to swing their antennas back and monitor the region continuously. So far, there is no proof that 3I Atlas produced the signal, but there is also no evidence that it didn't. And so the frequency remains under watch because history has shown that the most important discoveries arrive as brief, fragile bursts, signals that vanish before anyone realizes what they were. Meanwhile, the object itself is transforming. Its tail stretches longer each night, its brightness shifting unpredictably, as if its crust is riddled with vents that awaken and fade in cycles. Observatories tracking the motion notice that the nucleus doesn't behave like a single unified structure but more like a patchwork of independent active zones, each releasing dust and gas from different depths. For scientists, this is a rare chance, a chance to witness how a frozen body from interstellar space behaves when it is subjected to the unfamiliar heat of a foreign star. As 3I Atlas drifts inward, its coma may balloon into a vast glowing envelope, its surface may fracture into shards, and new dust bands may spiral off like threads unraveling from an ancient tapestry. These phenomena could expose its internal layers, layers that have been untouched since they formed in a star system we've never seen, orbiting a sun we'll never know. Compared to the smooth, tumbling oddity of Oumuamua or the comparatively normal activity of Borisov, 3I Atlas stands alone. It carries more dust, larger grains, more abrupt changes, and an inventory of volatiles richer than anything observed in interstellar visitors. This makes it one of the most valuable natural laboratories humanity may ever encounter. Yet this window might not stay open for long, because if 3I Atlas continues heating at its current rate, there is a very real chance it could shatter as it nears the sun. Such a breakup could obliterate its original form, but in doing so reveal its most ancient core, and so observatories on nearly every continent are running in near-continuous coordination. Optical telescopes measure the evolving brightness, infrared arrays map the hotspots, spectrometers decode the fleeing molecules, radio antennas hunt for rare emissions or repeated pulses. For the first time, scientists are building a multi-layered near-real-time archive of an interstellar comet's behavior.